And then the next one would be the rotary instancing, where you actually have a part, something like what's shown in the graphic here. So you're defining the toolpaths in one orientation, and then once it's completed, once that feature is completed, and obviously that feature has been duplicated multiple times in a rotary fashion, we just take the toolpaths and rotate it in the same manner to machine the other features rather than having to program each of the features separately. So that's 4-axis rotary instancing.
Now let's talk about rotary instancing in the 4th axis. So let's load that part. We'll go ahead and save that. And we'll do the rotary instancing. Okay, so we've got a 4-axis cylindrical part that's got machining features that are identical all around the part. So similar to the way we did in the 3-axis X, Y, and polar, you do a very similar in 4-axis. You program the one operation, or the control operations for the first feature, and then you're going to add a 4th axis index setup. So let's go ahead and go up to the 4th axis. And we'll
Important thing to, first thing you need to do, make sure as your machine tool is set up as a 4-axis, yep, with the rotary axis along the same axis of your indexing.
Right.
So.
You're right. I skipped that. So we're setting up the machine type as a 4-axis. It's a table similar to the last part we looked at. The rotary axis is along the X. Okay. And just need to make sure that your 4th primary rotary axis is correct for your machine tool, and also that your part is oriented in the correct orientation. And typically for all 4-axis parts, we have the coordinate system origin at the back of the part on the right-hand side. That's the typical orientation for rotary instancing. So in your, like I mentioned before, you just program the one feature, and then we're going to go ahead and go up to the 4-axis menu and pick rotary instance. So for this, we're going to define how many index positions we want to make. So we're going to, here for the incremental rotation, we want to tell it the angle between the instances. This, unlike the 3-axis where you told it to, the complete 360 degrees, you got to tell it how many angles or how many degrees there are between features. And for this part, it's 60 degrees. And we're going to have 5
copies
instances of it. So let's go ahead and generate that. So now what we're going to do is we got our original, and we're just going to copy these down into our rotary instance. Okay. So now when you select your rotary instance, you'll see all 6, or the original and then the 5 copies. It'll appear based on the rotary instance parameters you set as far as the incremental angle and the total number of instances.
Can you run the simulation, Don?
Yeah, we can do that. Let's go ahead and run the simulation. Let's double check, make sure we're all set here. And let's go ahead and run simulate. Oh, sorry about that. Turn the stock on, be better. Let's run that again. So we got our first instance, our second, and it's just going to work its way around for all 5 instances. So that's how easy it is to create a 4-axis rotary instance. You just program once, just like in all of our index machining. It's very easy once you understand getting the machine orientation set correctly, and then just programming your first instance, then the rest are really done for you. Let's go ahead and post this out. Do a post all. And let's go ahead and do, let's do this. So there's our rotary instance 1 with the also with the angles correct to rotate your 4th axis. And there's rotary instance 2, rotary instance 3, all the way down the line, 4, 5, and 6. So all in one part file, all you got to do is program one set of features, do a rotary instance, and it'll output all of the instances for you. Okay, we got plenty of time. Let's go to the 3+2 5-axis. This is an interesting part.